An application programming interface, API, is a set of protocols, tools, and definitions that allow software applications to communicate with each other. APIs define the rules and methods for different software components to interact, enabling seamless integration of services, data exchange, and system functionalities. They are widely used in web development, mobile applications, cloud services, and IoT devices to allow different systems to communicate without the need for direct human involvement. APIs simplify software development by allowing developers to use existing building blocks rather than starting from scratch. For instance, when building a web application, instead of developing a payment system from scratch, a developer can integrate with a payment gateway API like Stripe or PayPal. APIs offer numerous benefits to developers, organizations, and end users. One of the most significant advantages is improved efficiency. APIs enable developers to access pre-built functionality from other services, reducing development time and effort. This allows teams to focus on core features rather than reinventing the wheel. APIs also enable seamless integration of systems, making it easier for various platforms to work together, such as integrating e-commerce systems with payment gateways or shipping services. Scalability is another important benefit, allowing organizations to extend their services to a broader audience. APIs also facilitate automation, improving operational efficiency by allowing communication between systems without manual intervention. They also enable faster innovation, as companies can quickly build new features by leveraging third-party services. Finally, APIs enhance the user experience by enabling real-time features such as live updates and location-based services. This code on the slide illustrates a practical example of API usage, demonstrating how to interact with the OpenAI API using a Python script. It begins with the import of the OpenAI library, import OpenAI, which provides the necessary tools to communicate with the API. Next, the API key is defined, which is a secret code provided by the API service to authenticate and authorize requests. The API key ensures that only valid users can access the service. In this example, the script sends a question to the API using the prompt as you see. The question is, what is the capital of France? This line specifies the request, which in this case is asking the OpenAI API to provide the capital of France. The API call itself is made through the line completions equals openai.completion.create, where various parameters such as the prompt, maximum tokens, and randomness, temperature, are included. This constructs the request that the API will process. Pay attention that such parameters might differ from application to application. Once the API returns a response, the script extracts the result with the line, which stores the text response from the API. Finally, the print message statement outputs the API's response, displaying the answer to the user. This example highlights how APIs enable communication between systems, allowing developers to make requests and receive responses efficiently by using pre-built functionalities provided by external services. An API gateway is a server that sits between the client and a collection of back-end services. It acts as a reverse proxy, accepting all API calls, aggregating the required services, and returning the appropriate results to the client. API gateways are especially useful in microservices architectures, where multiple services make up an application. They simplify client interactions by providing a single entry point for all requests. An API gateway can handle various tasks such as request routing, directing incoming API requests to the appropriate back-end service. It also provides load balancing to distribute traffic across multiple instances of a service, improving performance and availability. API gateways help enforce security by managing authentication and authorization, ensuring only authorized users can access the API. They can also implement rate limiting to prevent clients from overwhelming the backend with too many requests. Additional features like response caching improve performance by reducing the need to repeatedly query the backend. API gateways also offer analytics and monitoring, providing valuable insights into API usage and performance. APIs are widely used across various industries and applications. For example, social media integration relies on APIs from platforms like Twitter, Facebook, and Instagram, allowing developers to embed social sharing features or fetch user data. Payment processing APIs like Stripe, PayPal, and Square are critical for businesses to handle secure transactions on websites and mobile apps. In the cloud services domain, APIs from providers like AWS, Azure, and Google Cloud allow developers to manage cloud infrastructure, deploy applications, and scale resources. E-commerce platforms like Shopify and Magento use APIs to integrate external services for shipping, inventory management, and order processing. In healthcare, APIs enable the secure exchange of patient data between systems, such as the FHIR, Fast Healthcare Interoperability Resources APIs used to transfer medical records. IoT devices use APIs to communicate with cloud services and other devices, enabling automation and data exchange. Additionally, APIs from AI and machine learning providers, such as Google AI or IBM Watson, allow developers to integrate intelligent features like natural language processing and image recognition into their applications. While APIs offer many benefits, they also introduce security risks, making API security best practices essential. The first and most important practice is to use authentication and authorization mechanisms like OAuth 2.0 to ensure only legitimate users and applications access the API. Rate limiting is also necessary to prevent abuse by restricting how many requests can be made within a certain period, which protects against denial-of-service attacks. All API communication should be encrypted using TLS/SSL (HTTPS) to protect sensitive data during transmission. It's crucial to implement input validation to prevent injection attacks, such as SQL injection or cross-site scripting (XSS), by ensuring that only properly formatted data is processed. API gateways play a vital role in security by managing authentication, throttling, and monitoring requests. Another important security measure is using short-lived tokens for session management, reducing the risk of token misuse. Continuous monitoring and logging of API activity is essential for detecting and responding to potential security threats, such as unauthorized access attempts or unusual usage patterns. It is also a best practice to version your APIs to maintain backward compatibility and improve security, allowing deprecated versions to be retired. Finally, API keys and credentials should be stored securely and not exposed in application code or version control systems. As a recap, APIs have become a foundational technology in modern software development, enabling seamless communication between systems, integration of external services, and automation of workflows. API gateways play a crucial role in managing API traffic, securing interactions, and optimizing performance. However, with the increasing reliance on APIs, it is critical to follow API security best practices to mitigate potential risks. By implementing secure authentication, encryption, rate limiting, and input validation, organizations can ensure their APIs remain secure, reliable, and performant.